It started with fire, a small discovery that changed the course of human history. From that moment, we've been chasing energy, more of it, faster, stronger. We moved from burning wood to coal, then to oil, from steam engines to nuclear power. Each step gave us more control over nature and more ambition to go further. But now, we're entering a new chapter, one where the energy we need may no longer come from Earth, but from the star at the center of our solar system, the Sun. How much energy does the Sun really produce every second? Could we actually collect all of it? And what would it take to build a machine powerful enough to surround a star? This is the story of the Dyson Sphere, the boldest idea in the history of engineering. A vision that could change not just our planet, but our entire future as a species. A Dyson Sphere is one of the most incredible ideas ever imagined in science. It's a huge structure built around a star, like our Sun, with one goal: to collect all of its energy. Right now, we only use a tiny fraction of the Sun's power. Some sunlight hits Earth, and we use solar panels to turn it into electricity. But what if we could go bigger? Much, much bigger. A Dyson Sphere would surround the entire Sun with millions or even billions of energy collectors. These collectors would gather sunlight 24/7 without clouds, night, or weather getting in the way. The energy could then be sent to planets, space stations, or even other star systems. It's important to know, a Dyson Sphere isn't always a solid shell like you might see in sci-fi movies. Building a solid ball around the Sun would be dangerous. It could fall into the star or break apart. Instead, scientists believe a Dyson Swarm is a better idea. A Dyson Swarm is a huge group of satellites, mirrors, or solar panels orbiting the Sun in a special pattern. They don't touch each other, and they don't block all the light. We just collect what we need, safely. Think of it like a cloud of tiny machines floating in space, all working together like one giant power plant. So why is this such a big deal? Because with enough energy, we could do almost anything. Power cities, launch starships, terraform planets, and unlock technology we can't even imagine yet. But why the Sun? Why do we have to build it around our Sun? Because the Sun is more than just a bright ball in the sky. It's a giant nuclear reactor, burning non-stop for over 4.5 billion years. It's the center of our solar system, and the reason life exists on Earth. Without the Sun's heat and light, our planet would be a frozen, lifeless rock. But how powerful is the Sun, really? Every second, the Sun releases about 386 billion megawatts of energy. That's a number so huge, it's hard to imagine. The Sun produces as much energy every second as 1 trillion nuclear bombs exploding at once, and yet, Earth receives less than 1/1000th of that energy, just a tiny slice of the total power. Now think about this. All the solar panels on Earth today collect only a tiny fraction of even that tiny slice. Most of the Sun's energy is completely wasted in space, never used by anyone. So, if we want real energy for the future, not just for Earth, but for space travel, colonies, and starships, we need to go directly to the source. We need to collect energy from the Sun itself. The Sun is also huge. It's over 1.3 million times bigger than Earth by volume. More than 99.8% of all the mass in the solar system is in the Sun. It's made mostly of hydrogen and helium gas, which it fuses into heavier elements. This process releases enormous amounts of energy as light and heat. And the best part? The sun still has billions of years of life left. It's stable, predictable, and incredibly powerful. Everything you'd want in an energy source. That's why the sun is the perfect star for a Dyson Sphere. The idea of a Dyson Sphere comes from a brilliant physicist named Freeman Dyson. In 1960, he published a short paper with a big idea. If a civilization keeps growing, its energy needs will grow too, and one day it will need to collect energy directly from its star. Dyson wasn't trying to describe a real building plan. Instead, he was thinking about how to spot advanced alien civilizations. He said, if aliens are out there, maybe they've already built something to capture their star's energy. If so, we might detect them, not by hearing their voices, but by noticing strange energy patterns from distant stars. That's where the term Dyson Sphere came from. It's a name we now use for any megastructure built to collect energy from a star. But Dyson wasn't the first to imagine this idea. Even earlier, in science fiction stories from the 1930s and 1940s, authors described giant space habitats around stars. Dyson just took the idea seriously and gave it a scientific purpose. Today, scientists still use his name when talking about advanced space civilizations. In fact, the Dyson Sphere is part of a system called the Kardashev scale, which measures how advanced a civilization is based on how much energy it can use. If you're curious about how humanity could reach Type 2 civilization, we made a full video about it. You can find it right here on the channel. It will help you understand why we're not even at Type 0 yet. But a Dyson Sphere could move us closer to Type 2 or 3, and that would change everything. Let's imagine what a Dyson Sphere might actually look like. First, forget the idea of a solid shell completely covering the sun. That's something you might see in a science fiction movie, but in real life, it wouldn't work. A solid shell would be too heavy, too fragile, and too dangerous. If it moved just a little bit out of place, it could fall into the sun and be destroyed. Instead, scientists think a better version would be something called a Dyson Swarm. This isn't one big structure, but a huge group of smaller parts, like satellites, mirrors, or solar panels. They would float in space, orbiting the sun like planets do. Each one would collect sunlight and send the energy back to Earth, or wherever we need it. Imagine millions of shiny metal plates flying around the sun. They don't touch each other, and there's plenty of space between them. But together, they look like a glowing cloud surrounding the sun. If you could stand far away in space and look at our solar system, you would see the sun in the center, with a massive ring or even a full sphere of sparkling satellites spinning around it. It would look beautiful, complex, and unbelievably massive. Each solar collector might be shaped like a square or a mirror. They could fold up like origami during launch, and then unfold once they're in space. The whole system would be smart and self-controlled, adjusting its position and keeping itself safe. To build a Dyson Sphere, or more realistically, a Dyson Swarm, we would need three main things: materials, machines, and energy. We'd need huge amounts of raw materials to make millions of solar collectors. Earth doesn't have enough, so we'd probably mine other planets, like Mercury, which is rich in metals and close to the sun. We'd also need advanced machines, like robots, to do most of the work. They would mine, build, and launch the parts into space. And finally, we need a lot of energy to power everything. That's why we would start by building solar collectors on Mercury to power the whole process from the beginning. It's a massive job, but not impossible. We just need the right tools, the right technology, and a long-term plan. Building a Dyson Swarm is not something we can do in one step. It would take many small steps over a long time, but the basic idea is simple. We start by sending a few machines to Mercury, because it's close to the sun and full of useful metals. Then, we set up solar panels on Mercury to get power. This energy runs the machines that mine the surface and build parts of the Dyson Swarm. Next, we need a way to launch the parts into space. Rockets are too expensive, so scientists suggest using railguns, long magnetic tracks that shoot parts into orbit. Each part unfolds in space like giant origami, turning into solar collectors. If we had the energy from a Dyson Sphere, the possibilities would be almost endless. We would have more power than every country on Earth combined, millions of times over. First, we could solve the global energy crisis forever. No more burning fossil fuels, no more pollution. Every home, city, and vehicle on Earth could run on clean, unlimited power. Next, we could do things that sound impossible today. We could terraform planets, changing the surface and atmosphere of places like Mars or Venus to make them livable. We could power massive space colonies where people live and work in orbit or on the moon. We could also build other megastructures like space elevators or giant computers floating in space. Even interstellar travel, reaching other stars, might become realistic because now we'd have the energy to do it. With enough energy, there's no limit to what we could create, build, or explore. Building a Dyson Sphere sounds amazing, but it comes with serious challenges. First, we don't yet have the technology to mine planets, build millions of satellites, or launch them efficiently. We would need smarter robots, better space infrastructure, and new ways to build in space. Second, it requires global cooperation. This isn't something one country can do alone. Political conflict could slow everything down. And finally, even a small mistake in space, like a collision or system failure, could destroy part of the project. Space is harsh, and the risks are huge. Some scientists believe we might not be the first to think about building a Dyson Sphere. If alien civilizations exist, and if they've been around longer than us, they may have already built one. But how could we know? A Dyson Sphere would block some of a star's light. Instead of shining normally, the star might look dim in visible light but very bright in infrared. Astronomers have been looking for this strange pattern, but so far, we haven't found clear proof. Still, the search continues. And maybe, one day, we'll spot one in a faraway galaxy. The Dyson Sphere isn't just science fiction, it's a vision of what humanity could become. A future where energy is no longer a limit, and space is no longer out of reach. If this inspired you, don't stop here. Check out our video on how we can become a Type 2 civilization to see the bigger picture of humanity's path forward. And if you enjoyed this journey, like, subscribe, and share it with someone who loves science and the stars. Together, let's keep dreaming bigger.